Good morning. Today we are going to talk about the properties of logarithms. But before we begin, please make sure that you have your worksheet and a pencil. We're going to do some examples on the back of the worksheet, so have that available. And have your calculator, just your regular calculator. You do not need your graphing calculator today. So let's start with properties of exponents. This is a review from Algebra 1. For example, when I take 2 to the 5th times 2 to the 3rd, what do I get? Well, when we multiply, we add exponents. So 2 to the 5th times 2 to the 3rd is 2 to the power of 8. 8 to the 6th divided by 8 to the 4th. When we divide, we subtract exponents. So 8 to the 6th over 8 to the 4th is 8 to the 2nd. And 3 to the power of 4 raised to the 5th. When we raise to a power, we multiply exponents. So this one is equal to 3 to the power of 20th. These properties of exponents go along with properties of logarithms. If you know the properties of the exponents, then you should understand the properties of the logarithms. The first property that we have is the product property, and this one states that when you multiply, if you are going to expand the logarithm, multiplication means to add. When we multiply, we add exponents. Quotient property, if you are going to expand and there is a division problem, division means to subtract. When we divide, we subtract the exponents. And if there is a power property, when we raise to a power, we multiply. So this exponent will come out front and be multiplied times the logarithm. Let's put that into practice and see what that looks like. First, we're going to start with expanding. Expand means to pull apart into separate logarithms. The log won't change and the base won't change. There are two things happening in this logarithm, and I'm going to show it to you separately. The first thing that's happening is this is 2 times x. And we said when you multiply, you add. So this is equal to the log base 5 of 2 plus the log base 5 of x to the 6th. The second operation we have happening is raising to a power, x to the power of 6. When you raise to a power, you multiply. So my final expansion here will be log base 5 of 2 plus, I'm going to bring this 6 out and multiply it, so plus 6 times the log base 5 of x. This is the same logarithm written in expanded form. Letter B, expand. Well, first thing I notice is the division. Divide means to subtract, so I'm going to go to log base 7 of y minus the log base 7 of 3x squared. Okay, there are two things you can do with this problem. You can leave the second half in parentheses, which tells us that the whole logarithm goes on the bottom because there's a minus, or you can distribute because there are two things going on here. I'm going to show it to you in both forms. So you could write the log base 7 of y minus the log base 7 of 3 plus, that 2 is an exponent, it's going to go out front, 2 times the log base 7 of x. Notice the 2 doesn't go with the 3 and the x, the 2 just goes with the x, and the same down here. Or you could show that both of these are on the bottom, the 3 and the x squared are on the bottom, by subtracting both of them. So this answer is correct, or this answer is correct. The log base 7 of y minus the log base 7 of 3 minus 2 times the log base 7 of x. Okay, pause a moment. I want you on the back of your worksheet to try letter C. Expand the log of 7x. Turn it back on when you're ready. Okay, check your work. For log of 7x, you should have expanded this to the log of 7 plus the log of x. Okay, your turn again. See if you can expand letter D and then turn the recording back on. Check your work. For letter D, you should have ended up with the log base 3 of 3 minus 2 times the log base 3 of y. The opposite of expanding is condensing. Condensing means to put together. So I'm going to take a look at letter A and turn it into a single logarithm. The first thing I will always write is the log and the base. This one is log base 3. And then I will take a look at how many operations we have happening here. Well, anything that's multiplied is an exponent. So that means that that is 7 squared. Subtracting means to divide. Here's another exponent, so I should have an x to the 5th on the bottom. So my final answer for letter A should be the log base 3 of 49 over x to the power of 5. Letter B. First I'm going to write my logarithm. This one is just a common log, log base 10. I start with x to the 2nd. This means to divide. So I have a 5 to the 3rd. This is also divide, so this also goes on the bottom of my fraction in the denominator, y to the 5th. My final answer here would be the log of x squared over 125 y to the 5th. Take a minute and try letter C on your paper and come back and compare it to what I have. For letter C, you should have ended up with the log of x plus 2 times 5. Normally we write coefficients out front, so I would prefer that you have this as the log of 5 times x plus 2. Pause while you try letter D. On letter D, I should have the log base 7 of x squared over 9. Come back and take a look at these later if you have problems while you're working on your worksheet. The last thing that we're going to look at today is called the change of base formula. The change of base formula helps you to evaluate any logarithm. The change of base formula says that the log base b of a is equal to the log of a over the log of b. Base on bottom. Remember that. Base on bottom. If I want to evaluate the log base 3 of 27, well, first of all, this is one you should be able to evaluate mentally, because this means 3 to the power of what equals 27. I know that 3 cubed equals 27, so letter A should be equal to 3. I can check that using the change of base formula. It looks like this. I would type on my calculator the log of 27 divided by the log of 3. Type that with me, please, on your calculator. The log of 27, you probably have to close up the parentheses around the 27, divided by the log of 3. And when I hit equals, it tells me that this is equal to 3. Letter B means 4 to the power of what equals 8. Well, I could figure that out because I know that 4 to the power of 1.5 is equal to 8. So this should be equal to 1.5. However, if I didn't know that, I could check the log of 8 divided by the log of 4, base on bottom, and that is equal to 1.5 according to my calculator. This last one, I'm not sure how I'd do without a calculator because I don't know 6 to the power of what equals 150. I know 6 to the power of 2 is 36, and I know 6 to the power of 3 is 216, so this should be an answer somewhere between 2 and 3. Checking it out on my calculator, I would type the log of 150 divided by the log of 6, and type with me the log of 150 divided by the log of 6, and we do get this equal to 2.796. So like we said, it's somewhere between 2 and 3. Okay? Go ahead and figure out letter D and then come check with me and see if you got the right answer. For letter D, you should have taken the log of 2 divided by the log of 7. This should be an answer that is less than 1, because 7 to the power of what is 2? Well, 7 to the power of 1 is 7, so I know this is something less than 1. And again, when I type it on my calculator, it tells me that it is 0.356 if I round to the nearest thousandth, which is indeed a number less than 1. Okay, so your 3 concepts for today are working with logarithms, expanding, condensing, and using the change of base formula. Please go ahead and complete your worksheet. Come back and check out this lesson again if you have any questions. Have a good day.